In this video, I'm going to show you how we can use half-angle formulas for evaluating expressions involving inverse trigonometric expressions. Look at these examples. Sine of 1/2 of tangent inverse of x. We want to write this expression in terms of x. We want to write this as an algebraic expression in terms of x, which means that we want to eliminate sine and tangent inverse from this expression. And we want to write it as an algebraic expression in terms of x. For simplifying these type of expressions, we start from sine inverse, cosine inverse, tangent inverse, whatever the angle we have inside the bracket. And we suppose that angle something like alpha, beta, theta, whatever you want to choose. So here we start and we suppose this angle theta. So we suppose theta to be equal to tangent inverse of x. We know that the answer of a tangent inverse always is an angle. X is a number, but tangent inverse of a number is angle corresponding to this number. Theta is an angle that its tangent is x. And immediately from this relation, we can conclude that because tangent inverse of x is theta, so tangent of angle theta is x. This is the relation between theta and x. So now we want to find sine of, attention, the expression that we want to evaluate is sine of 1/2 of tangent inverse, but tangent inverse is x. So we want to evaluate sine of 1/2 of theta. Instead of writing 1/2 of theta, we can write it in the form of theta over 2. We want to evaluate sine of theta over 2. Now for evaluating sine of theta over 2, we use half-angle formula corresponding to sine. Let me remind you the formula for half-angle for function sine. Sine of theta over 2 based on half-angle formulas is equal to plus minus radical 1 minus cosine of theta over 2. We use this formula for finding sine of theta over 2. So sine of theta over 2 equals plus minus radical 1 minus cosine of theta over 2. Now, if we look at this expression, we can see that in this expression we have to find cosine of theta. But here we have tangent of theta equals x. But we need cosine of theta, not tangent of theta. For finding cosine of theta, we use this relation and we draw a triangle corresponding to angle theta. We draw a right triangle and we suppose this angle theta. Because tangent of theta is x, so in this triangle, the opposite side to theta is x and adjacent is 1. Because remember, tangent is opposite over adjacent. Opposite side is x, adjacent is 1. Because we can write x as x over 1. Now we can use the Pythagorean theorem for finding the hypotenuse of this right triangle. Let's suppose the hypotenuse as a. Then a to the 2 is 1 to the 2 plus x to the 2. From this, a equals radical 1 plus x to the 2. So the hypotenuse is radical 1 plus x to the 2. Now we can use this triangle for finding cosine of theta. Cosine is adjacent over hypotenuse. So this equals plus minus radical 1 minus cosine of theta. Cosine of theta is adjacent over hypotenuse. So it is 1 over radical 1 plus x to the 2. All of this over 2. Let me make my radical bigger because it should cover everything. So This is the answer for this expression. Sine of 1/2 of arctangent of x is equal to this expression. So we have sine of 1/2 tangent inverse of x equals plus minus radical 1 minus 1 over radical 1 plus x to the 2 all over 2. Now let me show you how we can simplify the expression inside the radical. For simplifying the expression inside the radical, you don't need to really simplify it, it's up to you, but it's not bad to simplify this complicated expression inside the radical. For simplifying this, one thing that you can do is to try to eliminate this denominator. You can think to doing a common denominator in numerator, then divide by 2, but maybe this way is a little better, to multiply the expression in the numerator, and the denominator by radical 1 plus x to the 2. The reason that we do this is that we want to eliminate this denominator, and for that we multiply the numerator and denominator by the radical. If we do this, what happens? This equals radical. When we multiply this radical by 1, we have radical 1 plus x to the 2 minus, when we multiply this radical by 1 over radical, radical with radical cancels and we have minus 1 all over 2 radical 1 plus x to the 2. So this can be our final answer for sine of 1/2 tangent inverse of x. And it seems that I have forgot to put plus minus here, so it should be plus minus radical. But why we have two answers for sine of 1/2 tangent inverse of x? Because this expression should be equal to one expression. By why we have two answers, by plus minus. The choice of plus minus sign depends on the quadrant that 1/2 tangent inverse of x lies. Let me explain this to you. Please attention. If x is positive, if x, which is a number, is positive, then this angle is an angle in quadrant 1. And because this angle is in quadrant 1, sine of this angle would be positive. So we consider the positive sign for radical. So if x is positive, then for radical, we consider positive sign. And if x is negative, for radical, we consider negative sign. So this means that if we want to write our answer in the perfect form, we have to write our answer in this way. Sine of, what is this? Sine of 1/2 tangent inverse of x equals radical 1 plus x2 minus 1 all over 2 radical 1 plus x to the 2 when x is positive or 0. If x is less than 0, the answer this equals negative radical 1 plus x2 minus 1 all over 2 radical 1 plus x to the 2. So depending to the value of x, this expression equals this or this. And this completes the solution for this complicated question. Now look at this example. We want to evaluate tangent of 1/2 cosine inverse of 2 over 3. I highly recommend you pause the video here, try this question by yourself, and then continue watching the video. The process of doing this question is very similar to the previous question. Again, we suppose this angle as theta. So theta is cosine inverse of 2 over 3, which means that the angle theta, cosine of angle theta, is 2 over 3. So here we want to evaluate tangent of 1/2 of theta. This is theta 1/2 of theta, which is theta over 2. So we want to evaluate tangent of theta over 2. For finding tangent of theta over 2, we have to write this in terms of theta, because we have cosine of theta, not theta over 2. So now we use half angle formula for tangent. From half angle formulas, if you remember, tangent of theta over 2 equals 1 minus cosine theta over sine theta, or sine theta over 1 plus cosine theta. And also we have another answer, plus minus radical 1 minus cosine theta over 1 plus cosine theta. It's up to you to choose between these formulas. Here I prefer to use this middle one, but if you like you can use this one, but definitely not this one, because we have a plus minus here. We don't want to make our solution complicated. So for finding tangent of theta over 2, we use this formula: sine theta all over 1 plus cosine of theta. For finding the value of this expression, we need the value of cosine theta, which is 2 over 3, and we have to find the value of sine of theta. For finding the value of sine of theta, we can use cosine theta, which is 2 over 3, and for finding sine over sine theta, we can draw a right triangle. Let's suppose this angle is theta. This is a right triangle. Cosine of theta is 2 over 3. So the adjacent side is 2 and the hypotenuse is 3. We can use the Pythagorean theorem for finding the length of this side. Let's suppose the length of this side y. Then y to the 2 plus 2 to the 2 is 3 to the 2. If we solve this for y, y to the 2 is 9 minus 4. So y equals radical 5. So the length of this side is radical 5. Now that we have all the sides of this triangle, we can find the value of sine of theta and cosine of theta. Sine of theta is opposite over hypotenuse, radical 5 over 3. So this equals radical 5 over 3 all over 1 plus cosine of theta. Cosine of theta is 2 over 3, or if you look at here, 2 over 3. Adjacent over hypotenuse, 2 over 3. Now, the only thing that here we have to do is to simplify this expression. Radical 5 over 3 all over 1 plus 2 over 3. For simplifying this expression, you can multiply the numerator and all of the denominator by 3 to get rid of the 3 from denominator, or the other way is to simply add 1 to 2 over 3 with a common denominator, then divide numerator by denominator. But here I prefer, for simplifying this, to multiply all the numerator and the denominator by 3. In this way we can get rid of the denominators. We can eliminate the denominator. Radical 5 over 3 times by 3 is radical 5. This is numerator. For denominator, 3 times 1 is 3. 3 times 2 over 3, 3 with 3 cancels and we have 2. So the final answer is radical 5 over 5. So tangent of 1/2 cosine inverse of 2 over 3 is radical 5 over 5. I hope by watching this video you have learned how to use half angle formulas for finding value of expressions involving inverse trigonometric functions. If you like this video, please subscribe in my channel and see you in the next videos.